We've spent the last few days of class going over what a relation was, what a function is, the specific kind of relation a function is, how to identify um, various relations and the different ways we can see them with a mapping diagram, a table, a graph, how to find them, and all that kind of stuff with an equation. We use slope-intercept equation quite a bit, and we're going to put all of that together in this lesson as we go over our study guide. Okay. We have a test coming up Thursday and Friday this week, and this will help you get prepared for it. As we go through this, if you haven't done it, I suggest you do it um, along with me. And then if you have questions while you're watching this in class, please, please, please let us know, and we will do our best to help you. Okay. We will either go in a breakout room or I'll explain it to the entire class. So, once again, today we are going over our study guide for our test that is coming up tomorrow and the day after. So, let us begin that review process. Now, this is the Units 3A study guide. We are going to have our Unit 3 in two parts. Don't have to worry about that too much right now. Unit 3A is what we're going to be doing today. Now, this test is going to be broken up into two parts, or two objectives, I should say. We're going to have objective 1, which is going to cover these first SOLs, SOL A7, A, B, and E, functions and relations. I will break up this review video into two videos so it doesn't get too long. The first video will cover objective 1, and the second video will cover objective 2. All right. So that'll give you a little brain break in the middle of all this stuff. If you're getting a little fatigued. So let's begin. Let me move this. First, we always read our directions. All right. You don't want to start a problem without reading the directions because you may miss some important stuff. So, number 1 says, or the directions say, to circle the best answer for each question. Number 1 says, what is the range of this relation? What is the range of this relation? What is range? Okay. What is range? This is something we talked about quite a bit. If you aren't remembering it, this is something you definitely want to review. Range is always going to be our y. All right. Range is our y, or range will be our output. Range is our y, and range is our output. Okay. Those are the two things we're going to think about when we think of range. So, what is our y of this relation? What is our output of this relation? So, to do this, even though it's multiple choice, I'm going to walk you through step by step how I would do this if I were taking the test. I'm going to find the ordered pairs of each of these points, A through F, and then look at what my multiple choice answers say. So A is going to be, remember, this is our x-axis. This is our y-axis. This is going to be positive, positive on this upper quadrant. This first quadrant, the second quadrant is going to be negative, positive. This third quadrant down here is going to be negative, negative. And then this quadrant over here is going to be positive, negative. All right, so that's how we're going to think about our values, the sign of our values when we go through this. So A is going to be, we're going to go in the negative x direction 1, 2, 3, 4, 5 times, in the positive y direction 1, 2, 3, 4. So this is going to be negative 5, 4. Now B is going to be, we don't move at all from our origin portion for our x, but we do go up 1, 2, 3, 4 spots. So this is going to be 0, 4 for B. C, we're going to go 1, 2, 3 in the positive x direction and 1, 2 in the positive y direction. So 3, 2. D is going to be 1, 2 in the positive x direction and 1, 2, 3, 4, 5 in the negative y direction. So it's going to be 2, negative 5. That's parentheses, although it looks like a line. E is 1, 2, 3 in the negative x direction. So negative 3, and then 1 in the negative y direction. Negative 3, negative 1. F is going to be 1 in the negative direction, x direction, and we're not going to move in that y direction at all. So that's just going to be -1, 0. So now that we have these things plotted and we know that our range is our y, we can look at the y values on this for all of our ordered pairs on this graph and then pick our answer. Okay, so we have -1, 4, 0, 4, 2, and -5. Which one of these have all those? And when we're thinking about our range is always going to be listed from the smallest value to the largest value, and we're not going to have the repeats. So what is our smallest value here? We have -5 right here, and then we go to -1, and then we go to 0, then we go to 2, and then we go to 4. All right. So we have -5. Oh, we haven't seen anything like that. So that's definitely not going to be our answer. So we have -5 here. That's right. -3. I don't see a -3 anywhere in this graph. So we know it's not going to be B. And then we also haven't seen anything like C. And D is our only option left. So let's just look at all this. We have -5. Yep. Check. We got that one covered. We have a -1, 0, 2, and 4. So D is going to be our answer for this one. All right. I plotted this wrong. This is 0, -1, not -1, 0. Let me change that. 0, -1. All right, there we go. So number 1 is done. Number 2 says, what is the domain and range for the function above? Now this one may look kind of funky, but it's actually not hard at all. When we are telling or trying to figure out our domain and our range, looking at a graph, if you look at the first set of notes for this unit, at the bottom, it tells you how to do that. For our domain, we're going to go from the left to the right and look at what the arrows on this graph say, or look at how the graph is moving. Okay, so let's look at that one first. When we look from our left to our right, so domain, I'm going to put a little arrow there to let us know we're going left to right, and range, we're going bottom to top. All right, there we go. Going left to right, these arrows aren't drawn on this graph, but we know that this has arrows on it. So going left to right, our arrows are going in both directions. They're going to keep going in both directions, and that is going to cover all of the numbers on this graph, all real numbers. So as we have a domain for A as all real numbers, nope, that's not going to be our answer. B might, C might, and D might not. So we're going to cross those two off. We know those aren't going to be it. And so now when we look at our range, we're going to go from bottom to top and see what values we're going to have there. Going from bottom to top, we don't have anything there. So we know it's not going to be all numbers for that. But then we see our graph starts, and let me change colors. Our graph starts here, right at this part where y is equal to -4. Okay. Our graph starts at this point here. And where does it go? It goes up this way. All the values for y are increasing as we read this graph from bottom to top. So this is going to be a y is going to be greater than or equal to -4 because our y values are increasing. We can have -4 as an option. We can have -3, -2. We can have 80. We can have 70. All those values are greater than or equal to -4. Can we have -5? No, no, no. We can't have -5 because -5 is not on this graph. So we know that's not going to be an option. So this is going to be B, all real numbers for our domain, and y is greater than or equal to -4. Now let's look at number 3. Number 3 looks really funky. It's like, oh my gosh, Mr. Williams, we haven't seen anything like that before. You have. It's on one of the classworks or one of the notes. But if you haven't seen anything like this before, the way you're going to approach this is try to figure out what the domain or range is and use your process of elimination. So if I look at this from left to right, that's what domain is. Do we have arrows going in both directions? No. So we know it's not going to be all real numbers for our domain. So we can immediately cross out A and C. When I look from bottom to top, which is our range, do we have any numbers going? We have our graph going constantly from the bottom to the top. No, we don't have that either. It's all going in one direction. So we can also cross out anything that says all real numbers for our range as well. And what we're left with is our answer. So even though you may feel uncomfortable with this one, using that process of elimination gets us the right answer without thinking about it too much. Now let's go to number 4. Number 4 says our directions are to circle each relation that is not a function. That is not a function. A function, in case you've forgotten, I don't think you have because we've done it a lot in the past couple of days, but a function, the definition of a function is when our x values do not repeat in our relation. All right, so we're going to be looking for things, since we're looking for something that is not a function, we're going to look for things where our x values do repeat. So number 4, we have this table here. Do our x values repeat at all? Nope, those are not repeating, so that's a function that passes the test. This set here, -3, 1, -5, 20, -3, 4, 1, -5. We do have our x values repeating here. We have this x here and this x here. So this is going to be one we circle. You know what? I forgot I have a circle tool. Let's use that. And I'm going to change the color up a little bit. This is going to be one we circle. That is not a function because we have this -3 repeating. Now let's look at this mapping diagram. Like I said before, I always like to put inputs and outputs on top of my mapping diagram. And this test or this review study guide is no different. So that's my input there. And this is my output here. My output is my Y. My input is my X. There we go. Now, do we have any of these values repeating? When we write these as ordered pairs, will we write any of them twice? No, we will not, because these arrows are only going to one number. One go negative. Now this looks confusing because we have this -1 going to this 2, and then we have this -2 going to this 2. Now that just means we're going to have our y value repeated, not our x value repeated. So this is a function. Let's get to check. Now let's look at this graph down here. When we are trying to determine whether or not a graph is a function, we are going to use good old vertical line test. So I'm going to draw a vertical line. If you're working at home on the test or something like that, you can use a pencil and just hold it up to your screen to do your vertical line test. And what we're looking for when we do our vertical line test is to see, it's not completely straight, is to see whether or not more than one value is, if our line is touching the graph more than once. Because if it is, that means that it is not a function. So when we test this first one, oh, it makes it all the way through, passes no problem. So this is a function. All right. Now for this last one, this is a circle. And you guys have probably already seen it a mile away that this touches at 2 points the entire time, the entire way through. My line's a little short, so it doesn't touch there, but if it were long enough, it would. So this one is not a function. So we are going to circle the circle. Boom. So these two are not a function. This one, our x repeats. This one fails the vertical line test, and our x would also repeat if we were to graph it. All right, let's look at number 5. Number 5 says, write the ordered pairs in the boxes provided. 5 says, using the ordered pairs shown, create a function with a range of -1 to 4. So range is going to be y. So this is giving us y values. So we're going to create a function with these as our y values. When we're creating a function, another reminder, again, our x values will not repeat, okay? Our x values will not repeat. So we just have to have these as our range. So we can pick anything with -2 or with -1, 2, and 4. This one works. And since I can't drag and drop on this Kami document, I'll just circle the ones that we can use. This has -1, so we can use that one. We're going to look for one that has 2. Yep, this one has 2. We can use that one. And now we're going to look for one that has 4 in the range. Yep. So all these are y's. And we're looking for ordered pairs that have those values in the y, and those are going to be the ones we choose. Once again, if you have questions on any of these things or you're not understanding my thought process, ask me. All right. I'm right in the Zoom session. Come back and ask. Number 6, using the ordered pair shown, create a relation with the domain of 5, 9, and 0. So quick reminder, our domain is our X. That's a sloppy X. Is X. There we go. And this just says create a relation. The last one said create a function. This one is different because they just want us to create a relation. A relation, it doesn't matter if our X values repeat or not. So we just need to have 5, 9, and 0 in our X place. So this one works, 5, -1. What else works? We need a 9 and a 0. 9, 5 works. And then we need 0, 4. All those work, okay? Since this is a relation, our X values could repeat if we wanted them to, but we're just picking things that has this as our domain, that has us in the X coordinate position for these ordered pairs. Number 7. Directions. Select all of the correct answers. Select all the values of X, which the following relation will be a function. So that one seems a little bit confusing, but we are just selecting everything that makes this relation here a function, okay? This is our X. This is the value in question. I can do a circle on that. Boop, there we go. So anything that we can put in here that makes this list of ordered pairs be a function works. I'm just going to go straight through all of these and put a cross through or line through anything that doesn't work. So -3, do we have a -3 already listed? We do. We have a -3 here. Boop, A does not work. Let's see, 7. Do we have a 7 in our X place at all? 7 works. Do we have a 5 in our X place at all? Nope. We don't have, so 5 works. Do we have a 1? We have a -3. We have a -1. Even though this number is 1, it's negative. These don't have the same position on the number line, so this works. And they wouldn't be on the same position when you went to graph them. So 1 works. -1, we just see that we had this -1 here. -1 does not work. Next is 10. Do we have a 10 anywhere up here? We have a 10 here in this Y spot, in this Y coordinate pair location, but that doesn't determine whether something is a function or not. So 10 does work, okay? 10 works. And then G is -2. Do we have a -2 in our X coordinate value at any place? No, we do not. So 2 also works. Awesome, awesome, awesome. We are killing it. If you have any questions on that one may be confusing because you have to pick all the values that work, that fit. And once again, if you have any questions, come back to the Zoom session, ask them, and we'll get you all squared away. Number 8 says, determine whether the given relation is a function. Explain in words why or why it is not a function. So this is listed, it tells us the domain here, tells us our range. We could also put input, output, since it already has something there. I don't want to make it crowded, so I won't write input, output this time. When we are looking at mapping diagrams, the quickest way to tell whether something is a function or isn't a function is to see if more than one arrow is coming from from a single value in that domain spot. And that was in the notes, that first set of notes when we did relations. And is that happening in this case? Nope. That only has one arrow, that has one arrow, that has one arrow, that has one arrow, that has one arrow. So this is a function, is a function. And now we need to explain why it is a function. If we were to write out this mapping diagram in ordered pairs, our X values would not repeat. So that's going to be our explanation. Our X values do not repeat. There we have it. That is a function. Now let's look at number 8. I mean, not number 8, number 9. Number 9 says determine whether the given relation is a function, explain in words why, or why it is not a function. Same thing as number 8. So now we're going to look again. That has one arrow. That has, oh, that one's got 2 arrows, and that one has 1 arrow. So this is not a function. I'll write this one in red. Oops. To show us that it's not a function. Not a function. And it's not a function because our x values repeat. If we were to write this out in ordered pairs, we'd have -1, 7, 0, -3, 0 again, and then this 7, and then 1, 10. And since that 0 is being repeated, this is not a function. Excuse me. Number 10 says our directions for 10 and 11 are to evaluate. 10 says find f of -5 if f of x is equal to 2x squared minus 5x plus 17. Oh my goodness, that looks like a bear to deal with. But it's not. I promise it's not. In the classworks from 2 days ago or a day ago, in the classworks past, I showed you all how to use Desmos. So let's do another trick with Desmos. We're going to pull up Desmos. Desmos you will see in Schoology. It will be just right out in that page. You'll go to my Schoology page, and then boom, here you go. It says Desmos Graphing Calculator. You can use it in the Schoology page, or you can pull it out to have side by side. And if you're wondering how I did this side by side thing, I just drug the window. I clicked at the top, and I'm dragging it all the way to the side, and then I'm clicking, and it's letting me choose what window I want next to it. So now let's begin the process of number 10. First, we're going to write out this f of x in Desmos, so we have something to work from. So we're going to write f parentheses x. We're going to, whoa, that's weird. F of x equals, we're going to write out exactly how it says, 2. Now let me pull up this keyboard so you can see exactly what I'm doing. 2x, and then this squared value to get that power. I'm going to click this button here. Boop, there we go. Squared minus 5x plus 17. Going to hit enter. And now that I have this value, now I have this value plugged in, and you can click on your Desmos and drag. That's why I'm moving the graph around. Now that I have this function in place, I'm going to type in f, and I'm going to put -5. It's asking us for f of -5, so I'm just going to type that into the Desmos calculator, f -5, and I'm going to close that parentheses. And before I even finish typing it, it tells me, there we go, boom, boom, 92. So the f of -5 is 92. So I'm going to come back over here, go to my equation editor, f of -5, close that parentheses, equals 92. See, that wasn't hard at all. Now let's look at 11. This says if f of x is equal to -1/2 x plus 2, state the range if the domain is -6, -2, 0, and 4. So let's come back. I'm going to delete these. I don't need them anymore. And now we're going to type in this f of x. So this is going to be f parentheses x equals -1, 1/2. I need to get rid of that question mark. There we go. 1/2 x plus 2. Going to hit enter on that one. And I'm going to come back down so I can see my graph. You don't need to see the graph for this one, but I just like to see it. And it's giving us a domain. So what we can do is type in f of -6. Since this is giving us our domain, we want to find our range. And to find our range, we're going to type in our domain, which is our input. We're going to type in our inputs to get our outputs, and that's going to give us our range. So we have f of negative 6, f of negative 2, f of 0, f of 4. All right, so now I'm going to go back up and I'm going to look at all these. Let's minimize that keyboard. F of 6 is 0, so I'm going to type all these out now that I have plugged them into my Desmos calculator, and I'm going to list them the way we list them. So range is going to be R, colon, bracket, or it's curly bracket. I think they call them a brace, honestly. And then f of negative 6 is 5, comma, 3. And you know, I just realized I started to type these wrong. When we are typing these in, we want to type them in ascending order. We want to type them from least to greatest. So we're going to start with our smallest number and go up to our biggest number. So our smallest number isn't 5. Our smallest number is 0. So 0, comma, 2, comma, 3, comma, 5. So I went from the bottom up 0, 2, 3, 5, 0, 2, 3, 5. And I'm going to close that brace. And there we go. That's our answer. Do I still need Desmos? I don't think I need it anymore. Nope. You know what? Let's go ahead and show you how to do Desmos. How do you do this one with Desmos? And then I'll show you how to do it without Desmos. This is giving us our equation here. Excuse me. Y is equal to 3x plus 1. Y is the same thing as writing f of x. Well, let's do it like that. Y is equal to 3x plus 1. Okay, it will. It'll still put it in like that, but it's not easy for us to work with it that way. So instead of doing y, we're going to instead do f of x. All right, f of x is equal to 3x minus 3x plus 1, right? Yep. What is the value of f of negative 2? So we're going to type in f of negative 2. And here it gives us it right here. It's going to be negative 5. Then this one, B, is saying, what is the value of f of negative 1? I'm going to type that one in, f of negative 1. And that's giving me negative 2. So we have negative 2, negative 1. And now this is saying, given f of x is equal to 4, find the domain. For this, you want to actually look at the graph. So f of x is equal to 4. So this is saying when our y is 4, when y is equal to 4, find the domain, find the x, okay? So when our y is 4, we're going to find 4 on this table. What is x? And we actually have this ordered pair here, which makes this super, super easy. When y is 4, x is 1. And they tell us that right out. That makes that one pretty darn easy. 1. All right, that is the end of objective 1. So if you have any questions about this, go ahead and meet me back in the Zoom. Ask those questions there. I will answer them. And when you get them answered, go on to that next video and we will cover objective 2. Okay. Once again, if you are having troubles, ask the questions in the Zoom. So I know you can ask them privately if you don't want to ask them out loud, but ask them so I can help you. I will help you and then move on to objective 2. Okay.